to start with page 10, and we're going to use this idea of making these rectangles, and then we're going to try to tie it into area and perimeter of different building things. Like, and I'm just going to repeat myself because I didn't have the recorder on. A long skinny rectangle would represent maybe a good hallway, but not a great bedroom, right? So you want to think about the applications of these rectangles. Then you have a chart, and in your chart, you're going to record the length in the length column, like I did here. I have in rectangle A, I want you to put A through H here. My rectangle over here has a length of 1 unit, a width of 24 units, and like Thanos said, the perimeter is 50 units, but the area is 24 because I'm using 24 squares. You have to use 24 squares every single time. You have to use all 24 squares. And for this problem, not for every problem in your life, but in this problem in section 1.2, they're going to count this rectangle different than its rotation. So they're going to count the rotation as a separate rectangle. So to represent that in the table, I put a 1 by 24, but I also put a 24 by 1. Counting is 2 different rectangles today. So for the next 5 minutes, you're going to build the rectangles, all the different rectangles using all the chips, and then recording all the dimensions and perimeters in your chart. And order's nice. Even if you didn't go in order, you could probably look at your chart and then reorder it. But I'm just going to erase these dimensions and these rectangles. And then let's talk about order. Like if you split this in half, you could make, I don't think I quite hit half, but I can adjust it, right? I could do that rectangle, which is, what are the dimensions of that, Nathan?
2 by 12.
2 by 12, right? So this is a 2 by 12. So the length is 2, the width is 12. Perimeter, Nathan?
28.
28. Good job. Okay, let's stop the side conversation. Does everybody have that? A 2 by 12? Somewhere on their sheet?
Yeah.
Okay. Perimeter is 28. Area. What's the area, Hannah? It's still 24 because I used 24 squares. Okay, what's the next one following this order? I follow along a pattern of going from 1 to 2. Courtney?
3 and 8.
A 3 by 8. So I can move some of these over here, is what you're saying?
Yeah.
Like that, right?
Yeah.
You guys agree? Boys and girls? Right? So, what are these called? We've done this before. What are these numbers over here called? When I do 1 times 24, 2 times 12, 3 times 8, what's the next one? Factor.
Factors of a multiplication.
Yeah, they're factor pairs. So do we really need the chips?
Not really.
No, but the chips kind of give us a nice visual. So the next factor pair would have been a 4 by 6. And then the next factor pair, 6 by 4, right? So my question is, how do the chips help me, Graydon? Stop. Why did I skip 5? Somebody I haven't heard from. Grace, want to give? Well, go ahead and give it a try, Grace.
Because 5
5 doesn't go into 24. And how does that tie into the chips, Ava?
Well, because if you use the chips and you use it by 5,
Exactly. If I tried to do 5s, so both of you are correct, right? If I tried to make a 5 by something, they have a little problem. See my little problem? There's my little problem. It doesn't make a rectangle or a square. So factor pairs represent all the different rectangles with whole number sides that you could have. So going back to this chart, if I put all of these in, what's going to be the next one? Hannah? 8 by 3. And then Roman, what's the next one?
2 by
12 by 2. And then what's the perimeter of this 3 by 8? Yeah, Courtney?
The area of the 3 by, the perimeter is 22.
It's 22. Can you think of a quick way to do that? And the area is still 24 on all of these. Can you do that without looking at the picture?
Yeah.
What are you doing?
So I did
So imagine you don't have the picture, right?
8 plus 8 and then 3 by 3. And then I added both of them together and I got 22.
Okay, so she doubled the 8, doubled the 3, and added them together. Does anybody have a different way? That works nicely, Roman.
Oh, no, no.
Anybody have a different way? Wow, I do it differently. Your way works? I just add these two and double. So you could double either way. So for example, 4 and 6 make 10. I'm going to double and make 20. Or if I do Courtney's way, 6 and 6 make 12. 4 and 4 make 8. So 12 and 8 make 20. For me, that's more steps in my head. Where I just go 8 and 3 make 11, and I double and I get 22. Doesn't matter. They both work. 12 and 2 make 24. 14, so when you double, you get 28. And he knows that because it's already up here, right? Oh, you did it that quick? That's good. Actually, knowing it's in the chart is also good. It saves yourself time. So these are all 24. So that's the first part of the problem. The second part of the problem, as you look at this chart, which is also in your book, and you have to plot points. So I'm going to wait till everybody's listening. Actually, you're going to take this chart, and I'm going to zoom in on the chart a little bit, and you have to graph the length versus the perimeter. So that means you take the table, and you really are only going to be interested in the length and the perimeter columns, and you're going to plot points. So if you have a length of 1, what's your perimeter? 50, right. So you're going to go to your graph, and I made a mistake the first time I did this. I wasn't careful. These are counting by twos because it goes 0, 4, and there's a little space in between. And these are counting by 2s. So if you have a length of 1, it's halfway between the 0 and the 2. I'm going to zoom in again so you can see that. But our perimeter for a length of 1 was, look at your chart. It was 50, right? Because it was a 1 by 24. So if this is 1 and that's 24, and this is 24 and that's 1, from your chart we found out that the perimeter was 50. So we're going to go 1 by 50 and put that point there. Okay? And then when you look at the chart, I'm going to call that point A. Your job is to plot point A, B, C, D, E, F, G, and H. If you're in a different order, that doesn't matter. Your points will have different names, but your shape should be the same. So do that in 5 minutes. And look at my points. I'm going to zoom in on my graph here. Okay? Actually, I'll bring this over here. Your graph should look like my graph so far. The letters might be different, but the position of the dots should be the same. Does your graph look like that? Then you're going to pick up your pencil and give your best effort on drawing a curve, because this is a curve graph, and try to hit all the points as smoothly as you can. When you get to D, you're going to dip below, and you're going to come through, and then I'm trying to aim for H, which I don't always hit, but that time I did. So take a minute to draw that curve. So here's the real challenge of the day. Your goal, by the time we have our next quiz, is to be able to take a graph like that and answer a lot of questions. This book starts with this being about a construction project. And we talked about the hallway. This, rectangle A, it's kind of like a hallway. It'd be a bad bedroom. You know, for the most part. A good bedroom has a lot of room in it, right? These all actually have the same amount of area, but the shape of a good bedroom would have a little more width, so you could put things like a bed in there, right? So the other thing the book talks about is if you take a long skinny rectangle like this one, it has a perimeter of 50. So if we had that long skinny rectangle, and think about if you had to build around that hallway, you would have to have 50 units of like wood, wall space. That's a lot more than a perimeter of 20, right? So for a bedroom, if you had instead of a long skinny hallway, if you had something like shape D, that might be more like a bedroom, maybe more like a bedroom. And there's a couple advantages here. In a bedroom, you have, let's say this was a 4x6. And of course, this could be yards or, you know, it could be different units. Okay? But the shape is, it still has 24 square units of area. But now the perimeter is only 20, so it would take less materials to build the wall. See the advantage? And you could actually fit wider things in there. So the book talks about that. We're going to talk about that a little bit more, but you're kind of thinking of those ideas. And then you have to answer some questions. So I want you to go to this next set of questions. And first of all, just describe the shape of your graph, Ava. How would you describe it in your own words? Yeah. Yeah. It's kind of like, it's not really a V. Yeah, it's a curve. Because a U is like a curve, right? It's a curve, and if you remember, I think, maybe that wasn't in this class, but it's a curve that kind of starts high, and then dips down, and then curves back up, right? So the biggest thing is it's a curve shape, it's decreasing and then increasing, it's not a line shape, okay? The other thing is you have to be able to look at a graph like that and find the rectangle with the greatest perimeter. That's not too hard if you can read the graph. So we're going to zoom in on this now and then point out a letter that has the rectangle with the greatest perimeter. Raise your hand if you can do that. Who haven't I heard from today? I feel like I've heard from, and me, but I haven't heard from you. A and H. They have the rectangles with the greatest perimeter. So even if you didn't have the rectangles, you are going to be using the graph reading. Okay? So the perimeters are vertical axes. So A and H are the rectangles with the greatest perimeter. So you should be able to find them. And then how would you describe them? What are, A had a length of how much? No, it has a perimeter of 50. A length of, you have to look down here, right? So that's a tricky thing. So So when I look at A, if I didn't know the length, I would take like a ruler or something like a very thin line, and I would go to A, and I would drop like a vertical line down. Can you see that? It's kind of too light, isn't it? Let me make that a darker color. So I would, maybe it just needs to be a little thicker. I would drop that vertical line down. Can you see that very well? Not at all. So thicker, not dotted, pretty bright. How about that? It's a little thick, but for you guys, then you can see now the length is 1. Do you see that? So even without the rectangle, you should be able to read the dot and then project down and tell me what the length is. So if it is a perimeter of 50 and a length of 1, and you didn't do that exercise, you should still be able to figure out the missing side. Because you know the perimeter is 50. You have to do what, Courtney?
You can minus the 1 on each side.
So subtract 2 and you get 48.
You get 48, and then you have to split it in half because for both sides, not just for one.
And we did that on our last test. So even though the graph doesn't show a 24 anywhere, you should be able to use the perimeter, which is 50, and the length, and be able to tell the area. We still haven't answered the question. We want to describe the rectangle. So when we look at that rectangle, how would we describe it? Long, right? Long and thin. Long and skinny. Long and skinny. Okay, and we're going to go one more question here. Describe the rectangle with the smallest perimeter. So let's see, go back to the graph. Where's the smallest perimeter? Somebody knew. Yeah, Aaron? D and E, because they're the lowest point, right? So then, what's the length of D? D's perimeter. What's the length? For the rectangle D, what's the length? 4. Do you see that? How about you, Aaron? Yeah? So if I go back to the 2-page view, in order for me to describe it, I need to think about what it looks like. So D and E are both the rectangles with the smallest perimeter, and I know the length is 4. The perimeter was 20 on those. So Aaron, how are you going to find the missing side? 4 and 4 make 8. 12 by 2. 6. So it looks more like this. So how would you describe that? Would you describe it long and skinny? Harder to describe, right? You could say something like the length and the width are closer. You know, it's closer to a square shape. That would be one way. It's not a square, but it's closer to a square shape. That could be one. Okay. Not long and skinny. Yeah, Grace.
One thing about that I learned about finding the biggest perimeter and the smallest perimeter.
Yeah.
I found that what helps me, you look at once you find all of the factor pairs, the numbers and the factor pair that are closest together for the small.
That's right.
And then the ones that are about as tall.
Great thinking. So go back to the factor pair list. The smallest perimeter, these are all the same area of 24 here. But remember, if I add these together, I get 11, and I double it, I get the perimeter of 22. If I add these together, I get 10, and I get the perimeter of 20. 4 and 6 are closer together than 3 and 8. They have the smallest perimeter.
And then the biggest, and the biggest.
1 and 4 are really far apart. 1 and 24 are really far apart. They have the biggest perimeter. Great, great contribution. That's a great thing to think about. You kind of beat me to the punch there, which is super. Okay, so one more question then. How can you look at a graph? I think we sort of answered it, even though I didn't mean to. And figure out what the area is without knowing the area. Like this graph, if I move it over, how can I use the graph and figure out the area when there's only length and perimeter? Like for G. On G, I can tell the length is 12. And I know the perimeter. I can read over here and see the perimeter is 28. How can I figure out the area? Know the perimeter is 28. So it's the perimeter, not the area. I think you're doing are you doing area?
Yeah.
Yeah, that we have to figure out this, don't we, to get the area?
What one said 28?
No, the perimeter, the whole adding around is 28.
Divided or minus or?
Yeah, it would be minus, so finish it off, Courtney.
So, you can minus 24.
Because 12 plus 12 is 24.
And then you can split it in
To 2, right?
two, and then split it in half.
So how's my picture?
And then
How's my picture?
good.
Good?
Well,
It's saying that this is 2. How's my picture?
very good.
Lousy, right? Let's fix my picture. But did it matter? My picture helped me think. Now I'm going to go, wait a minute, my picture really should look like this. Can I figure out the area? Keep going, what do you do?
So, then you do 2 times 12, and you get 24.
Yes. Okay, so this is the deal. That's the kind of thinking you have to do for the 3 homework problems.